Recursion is a very powerful concept that is when a function can call itself. Some functions are not recursive just because of the way they're written, but most would be. And if you start out to create a function that will be recursive, that will wind up calling itself, there's a few things you need to be aware of. One, excessive recursion can cause great problems because you generally will be working within a limited amount of stack space. The stack can be overflowed or even underflowed if things are popped off incorrectly. That's generally not under your control, but you can overflow the stack with excessive recursion. Let's say that you're sorting a very large array or something like that, and you've written your own sort, your own recursive function which calls itself. Every time you do the call, more variables are pushed onto the stack, which is where you're setting up all of your locals and automatics, and you can wind up with an issue. You're probably not going to be doing that kind of coding for some time, if you ever have to get into that, but I just want you to be aware of it. But recursion is when a function calls itself. Now here we have right out of KNR a little function called printd. Now printd takes in an integer n, and it's going to print it out as a decimal. We know that printf does that for us, but we like to reinvent the wheel around here. Here's what printd is going to do with this integer that it gets in. If the integer is negative, if the number that it's being asked to print is less than 0, the first thing we'll do is stick out a negative, a minus sign. And then we will flip n. We will say that n equals negative n, which will flip it over to a positive. Now we get out of that if, and now we start working on a positive number. If it was not negative, of course, we hit down into here. If n divided by 10 has a whole value here, in other words, the n is larger than 10, and it's over in the tens place, or hundreds, or thousands, it's a larger number, then we're going to call ourselves. We will call ourselves with n divided by 10 and get that number down smaller. If the numbers 1, 2, 3, and 4, it's too large for us to print one character at a time, so we divide it by 10 and call ourselves again. Check it to see if it's 0, it's not. If it's still can be cut down, we divide it by 10, call ourselves again and again until eventually we're dealing with a single digit. We're not dealing with a double-digit value. When that happens, we put char and modulo 10, so that's the remainder of n divided by 10, plus a character 0. A character 0 added to the actual value number will create the ASCII printable character. So we put out the printable character, and then we return from printd. Well, if there were multiple printds calling each other, when we return from printd, we actually return to here, the next statement after the last time we called printd. And this put char will then be performed, which is the next digit in, say, 1, 2, 3, 4. We would have printed out the 1, and now we print the 2, and then we'll exit here, come back into the next statement after the call for the number 3, exit, the number 4 will be printed, and then finally we will wind our way back out of this recursive set of steps and leave printd entirely. But that is recursion, and recursion is a function turning in on itself, calling itself repeatedly, and it's a good thing to remember that you don't want excessive recursion. It can blow off the stack, and it's a very powerful part of C programming, though.